To calculate the correct overcurrent protection device OCPD and conductor sizes for a 75 kV-ampere three-phase transformer with a 480 volts primary and 208 volts secondary is essential to follow a step-by-step approach. Firstly, the calculation for the primary OCPD involves determining the primary current. The formula used is primary current equals kilovolt-ampere divided by the square root of 3 multiplied by the primary voltage. In this case, it's 75 kilovolt-ampere divided by the square root of 3 multiplied by 480 volts, which equals approximately 86.5 amps. Since you can't use 86.5 amps directly, you must use the next standard fuse size. According to standard electrical practices, the primary OCPD should be a 150 amps fuse. Secondly, the secondary OCPD is calculated similarly, but using the secondary voltage. The formula is secondary current equals kilovolt-ampere divided by the square root of 3 multiplied by the secondary voltage. That's 75 kilovolt-ampere divided by the square root of 3 multiplied by 208 volts, resulting in approximately 212.6 amps. Using the next standard circuit breaker size, the secondary OCPD should be a 225 amps circuit breaker. Thirdly, for conductor sizing, begin with the primary conductor. The allowable ampacity for number 1 American wire gauge or AWG/THHN at 75 degrees Celsius is 110 amps. Since the required ampacity for the primary side is 90.2 amps, number 1 AWG/THHN is sufficient. The National Electrical Code or NEC specifies ampacities based on conductor type and temperature rating, and it is important to use the correct ampacity for the conductor and its installation conditions. Finally, consider the secondary conductor. The allowable ampacity for 3/0 AWG/THHN at 75 degrees Celsius is 225 amps. With a required ampacity of 208 amps on the secondary side, 3/0 AWG/THHN is adequate. It is crucial to ensure that the conductor ampacity is equal to or greater than the calculated current to prevent overheating and potential hazards. Therefore, to summarize, the primary OCPD should be 150 amps, the secondary OCPD should be 225 amps, the primary conductor should be number 1 AWG/THHN, and the secondary conductor should be 3/0 AWG/THHN. This calculation method ensures compliance with electrical codes and safe operation of the transformer. Always consult local electrical codes and regulations for specific requirements and consider consulting with a qualified electrician for complex installations.